This video is on chapter 24, the binomial theorem, and in particular theorem 168, the binomial theorem. So first of all, when you read this, you see sort of a frightening looking formula there. So what I want to do with this, since the proof is in your notes, I won't go through the proof, but I want to explain the theorem and the material behind the proof. And I'm going to start by explaining how to choose k objects from a set of n. So we have a formula. This is called n choose k. And it's a number of ways of taking a set of n objects and choosing k objects when order does not count, when order is not important. And that formula is n factorial divided by k factorial times n minus k factorial. This is a number of ways of choosing k objects from a set of n. There's other notation for this. Sometimes you'll see an n over a k, sort of like division without the division sign, and brackets. This is just the same notation. This is different notation for this. It's the same formula. This formula is what the binomial theorem is based on. So the binomial theorem itself is a formula for a plus b to the n. First of all, let's write out what this is. We have a plus b times a plus b times a plus b and there are n factors. So there are n of these factors. The binomial theorem talks about, or tells us what the coefficients are. So when we multiply all of this out, what are the coefficients of all the terms? Some of them are fairly simple and some of them are more complicated, and we have to use the formula that I just showed you. First of all, you have an a to the n term. You take a times a times a times a down to these n factors, you have an a to the n term. At the end, you have a b to the n term, because you have b times b times b times b times b. What about the middle terms? One thing we have here is then we have an a to the n minus 1 times b. We have these types of terms. The question is, how many do we have? Well, how do you get one? You get one by choosing a b from one of these factors and the rest a's. So for example, you have a b times a times a times a down to the a's. What's another way to have one of these factors? Well, we would choose this b, and then a. The rest would be a's. How many choices of b do we have? Well, because there are n factors, we have n choices of b. Now, here's where things get a little bit more complicated. What's the next type of term we have? We have, we have an a to the n minus 2 b squared term. How do we get one of these terms? Well, we choose two of our terms to be a b and the rest a's. How many ways are there to do that? N choose 2. We choose two b's from our set of n. So to save space, I'm going to use the second notation I showed you. There are n choose 2 of these terms. We'll do the next one. We also have an a to the n minus 3 b cubed. How many of those terms do we have? We have n choose 3. Finally, we come down to this term. We could follow the same logic that we did here, or we could say, well, finally, what is this last term here? Well, yeah. So this is going to be, we're going to have an a to the n minus 1, which you'll notice is just a. And then we'll have a b to the 1 okay. I didn't save room for my coefficient. How many of these terms do we have? We have n choose n minus 1. This is actually the same as n choose 1, which is just n. So even though I wrote this coefficient differently than I did this one right here, this term here is actually equal to n. And this is a. So what I actually have here is I have n times a this should be b to the n minus 1. So the sums of the exponents should always be n. So this is a to the 1, and then we have b to the n minus 1. And then our last term is b to the n. This is the binomial theorem right here. So we have our n choose k's all the way through. And so when you look at this, the formula that's given in the notes is we have the sum of k equals 0 to n, and we have n choose k that's n choose k, and then for the a we have n minus k and b to the k. That is another way of writing this.